Good evening, ladies and gentlemen. It's my pleasure to welcome you all to the webinar on architectural lighting designs organized by the Electrical, Electronics and Telecommunication Engineering Sectional Committee of the Institution of Engineers Sri Lanka. Today, we are here to highlight the importance of architecture in our daily lives and showcase the artistry and precision that goes into creating beautiful and functional buildings while meeting technical and safety requirements. Without further ado, I'd like to invite Engineer Chamil Edrimuni, Chairman of the Electrical, Electronics and Telecommunication Engineering Sectional Committee of IESL to deliver the welcome speech.
Thank you, Engineer Sandima. I hope you can hear me.
Yes, sir.
Thank you once again for that kind introduction. Good evening, everyone, distinguished guests, ladies and gentlemen, and my dear members. It is a pleasure to be here with you all today. As the chairperson of the Electrical, Electronic, Telecommunication Engineering Sectional Committee of the IESL, I'm delighted to welcome you all to this webinar on architectural lighting design. I believe our committee has been bestowed with a huge responsibility for advancing the science and technology of electrical, electronic, and telecommunication engineering in our country. And it is an exciting time to working towards this goal. Architectural lighting design plays a critical role in enhancing the visual appeal of the structures and the comfort of those who occupy them. It is a field that requires a unique blend of technical and artistic skills. Proper lighting design can have a significant impact on energy efficiency, safety, and overall well-being. I encourage you all to take full advantage of the opportunities presented at this event to learn from one another and to exchange ideas and knowledge. Once again, I want to thank you all for being here with us today, and I look really forward to an exciting and productive event in this evening. Thank you, Engineer Sandima, and over to you.
Okay, thank you, Engineer Chamil Edrimuni, for those insightful remarks on the importance of architectural lighting design and for welcoming us to this webinar on behalf of the Electrical, Electronics, and Telecommunication Engineering Sectional Committee of IESL. Now, we are delighted to have Engineer Navodana Kankanamge, the Deputy Chairman of the Electrical, Electronics and Telecommunication Engineering Sectional Committee of IESL, to provide the opening remarks for this event.
Engineer Sandima, I am afraid that he is able to do this because he is having some difficulties in his health. I think I have given that as well, so that we can introduce the speaker.
Okay, sure. Okay,
yes.
Sure. Okay, let's continue. Thank you. Okay, now we are honored to have with us our keynote speaker, Engineer Nilusha Rajapaksha, the Director of Candela Lighting Design Private Limited since 2018. Engineer Nilusha is an experienced lighting designer with a demonstrated history of working in the design industry, skilled in computer-aided design, engineering, project engineering, and electrical design. With over 16 years of experience in the industry and having worked on several high-profile projects, Engineer Nilusha is an expert in the field of architectural lighting design. In addition, Engineer Nilusha is a certified Dialogues Evo trainer, Dial Germany, and the ambassador of Sri Lanka, Women in Lighting. We are thrilled to have her share her knowledge and expertise with us today. Please join me in welcoming Engineer Nilusha Rajapaksa to share her knowledge with all of us now. Thank you.
Hello, Sandima. Hello.
Hello, Engineer Nilusha. Yes, we can hear you clearly.
Okay, thank you. I'll share my screen. Sandima, can you see the screen?
Yes, of course.
Okay, thank you, Sandima. Thank you for nice introduction.
You're welcome.
Today, our topic is architectural lighting design. I hope everyone loves lighting, isn't it? And it's amazing to know what you're thinking about lighting. Now, generally, every day, I'm thinking of lighting because it's my profession. I have to do that. But what you are thinking about lighting? So today we'll talk about architectural lighting designs. Normally, it's defined as a combination of art, science, and technology. Most of the time, this science and technology part, as engineers, it's covered maybe in a degree course, or maybe you have learned yourself, self-study. But this aesthetic design part is where I think you need some support. So then, in this presentation, we are going to talk about our natural light source, light distribution and direction, color rendering index, color temperature, colors in design, and also lighting effects. Maybe this is new to you about dark sky concepts. And I want you to start yourself. So there's a portion for that as well. What is our natural light source? We get daylight from our sun. Like Sri Lankan countries like Sri Lanka, we have excess daylight, but not some other countries. What we have to do with this excess daylight? Still, we can use daylighting as architectural lighting design for the built environments. Maybe we need to do some kind of shading, kind of limiting entering to our built environment, built spaces. So still, we can use daylight also as a lighting feature during the daytime, because we mostly artificial lighting we use at the night time. And there is a problem with the heat as well. So I think now they are developed a lot of things to cover the heat and get only the lighting inside. Maybe a limited amount, because we have, I think, maximum 100,000 of lux in the daylight. We don't need that much. So these are the big buildings, that how they take a daylight into their buildings, into their structures. So this architecture also evolved with this daylighting availability and its direction. Uh, Basically, it depends on certain countries like us, Arabic countries, where we have excess of daylight. So they will have small windows, small doors to limit the daylight because it comes with the heat. But in other part of the world, they have large glass windows to collect the daylight because they don't have much daylight on those areas. So we really need to imitate the daylight properties. So even though daylight will help us to reduce the energy cost during the daytime and improve the occupant satisfaction, maybe increase the workers or students' productivity. Sometimes it will increase the sales of any outlets if you mix up with the daylight during the daytime. And of course, it'll improve the health. So we have our circadian rhythms, our biological clock, which goes with the sun. So all these things considering, it's really important to have daylight during the daytime within our spaces. And there is a psychological requirement also of the people to know what time is the day to day and which orientation we are in the environment. So in that case, this architecture is developed to receive some daylight, to see the view outside. So those things are required when you are designing. So in the evening, we will have a different color of the daylight, not like morning. And then slowly, we will switch on our artificial lighting. So it will be a mix of daylight and artificial lighting together. And then it's night where we will full switch on our artificial lighting. And then it's midnight. So likewise, we will see the color of the sunlight from morning to night. It differs. The color of the light, we normally, as a technical term, it's called color temperature or the CCT. So daytime we will have 6,500 to 4,000 Kelvin, and then evenings we will get some warm colors like 3,500, 3,000, then 2,700, and even below that. So this is very important to know, because we are living with these colors of the natural light. So if we are imitating this, or if we are putting some artificial lighting, it's required to follow the same thing, either mixing with the daylight or changing the color of the artificial light different time of the day. So this, you will see the different colors, different white tints of the light. And with the same topic, I will continue with this McAdam ellipse criteria, even though it's a very technical term. We will just look into a very simple way of that. So when the color is changing, if you are manufacturing these LED, say LED light fittings, because we normally use LED light fitting nowadays, So you can see even the white color of the light, you will have different tint. Bit of yellowish, bit of cool white, bit of bluish, likewise. So if you get these steps, if you go with like 7 steps, you will see within the 7 steps ellipse, there are visible color differences. But if you go with this 2-step area, the visible color difference is very low. I mean, you can't see at all. So this is the point with this color temperature. When we are designing, it's really important to go with the same color of at least same application, same project. So this is one thing we need to keep in mind. If we fail to do so, we will see the visible color differences within the same type of fixture. I mean, with the same application that we have already installed. So color consistency is a must when we need to do so. But at the same time, you can see that we can mix up these colors to create a nice visual effects. So this is one example where you will have uh, basically warm colors used for inside, and for the facade you have used to some of the cool white, or say somewhere around 3500, 4000, or kind of a color temperature. So next part is like light distribution and direction. This is really important because sometimes we don't know which direction we should focus on, which things we need to highlight, uh, what are the accent lighting required for a space, and what is the limit of that. This is basically a limit of distribution we are talking about, and the direction. So example here you can see from narrow beam, narrow distribution of light to a very wide flood type distribution. So what is the difference? So what is the difference is the highlighting area will be different. So actually we need to think about which part of the tree we need to highlight. Now this example you can see different tree types, and the canopy is different in some of the trees, and then how you're going to light up, which part you will light up of those trees. So it's different to type of the tree. Maybe we have to use wide angles, maybe we have to use very narrow beams. Likewise, it depends on how we're thinking about the lighting design for that particular application. So here you can see very narrow beam just to light up the teapot and stuff. So it will highlight only that. The rest of the area remain dark. So is that our intention? Yes, then we need to limit our light distribution angle. So I hope you know how to measure it, the beam angle. Here it says the same concept, like what you want to focus, what you want to highlight, you need to do only that part. You don't need to distribute unnecessary your light beams and just make it waste. This is the technical parameter of that, which we call photometric data. This data we can have it from the light fitting manufacturers. From that, we can understand many of the features of the light fitting, how the distribution, what is the direction. Now here it's up and down both, uh, and how much it's distributing, which angle it's distributing. So all this information we can get it in advance before we start the design. So distribution, maybe you have seen sometimes we have used downlights in certain areas, but it has like beam angle, we call it the 50% maximum concentration in the middle of the light fitting distribution, and the spill light will go up to another 50%, and it will give a very distributed way of lighting effect. But if you cut off that spill light, so the 100% concentration will be on the main beam angle. So then you will see a very like cut off area. So other area will be totally dark, maybe a little of indirect lighting, but it will be totally dark, and you will focus only on the if it is a round aperture, it will give a round spot. Likewise, you can have rounds, whatever the required things that you need to uh, do your lighting design. This is another way of distributing lighting. It's called uh, wall washing. So basically, it will start from the top of the wall, and it will go down to the bottom of the wall. So that will give a symmetric distribution mostly over the wall, and there will be no scalp or things like that. So this is basically, we call it wall wash effect. And sometimes we limit with our uh, lighting to make a different design. So it's used kind of art cut in the some kind of a plate and fix into the light fitting. So you will get a some kind of light and dark combination of light brush as the output of that light. And this is something you can think more about light distribution. It's distributing upwards, but it's scattered. It's not directly going upwards. So in this kind of cases, the lenses or the filters are playing a big role in these light fitting designs. So maybe you will have colored filters or uh, transparent filters, and it will not have a smooth surface. So that's why it's giving a scattered kind of effect. But still, these things can be improved in and designed in many ways, and maybe some of the projects already use this type of sliding effects. The next thing is we are going to talk about CRI, color rendering index. Why it is so important is the daylight, we call it that is color saturated, and it has the most say 100% of the CRI properties. That's why we see the correct color under daylight. But with the artificial light, we may not see the correct color. Actually, this is a problem I have seen in many of the project designing. They don't have much idea about this color rendering index. And sometimes when the fittings are installed, the area looks so dull. That may be one reason is you have not gone through this color rendering properties well, and maybe it has very less values. Here the question is asking seen red. So here is why red? Why we asking only red? Because that there is a problem with the red color. Now this is the same thing I explained to you. Like with the sunlight, we have CRI say 100%, and we are seeing the bright color of the object. But with artificial lighting, it's not so that maybe CRI 80, 70, even 50. So we are not seeing the correct color. This has a lot of problems with the, even when you're going to buy clothes, sometimes under artificial lighting, you may not see the correct color. Once you come back home, you will see the color is different. So that is one. Another important thing is that's what we talk about. We need to mix the daylighting as much as possible to this showrooms as well. I mean, if we are unable to provide higher CRI light fittings as the sources there, so it's better always to mix with the daylight and get the properties that we are lacking of. So this is the reason. Actually, CRI is not CRI value is not a measured value. It's average value calculated from each R1, R2. Likewise, these values. So red is almost 0, or even it has some kind of a value, but that is considerably low. The reason is still the technology not developed so far to increase this R9 property to a higher value. So if we are calculating say R1 to R8, those colors, you will get CRI as 81. But if you totally from R1 to R15, if you calculate the average, that will goes down to 75. Here you can see the colors exactly, I mean the right colors, saturated colors as it is. So the light source should have higher color rendering index in this case. Mostly museums, art exhibitions, and even where the color sensitive applications where you need to see the color exactly, cloth manufacturing. I mean, lot of applications are there where you need to consider this CR, right, as a uh, highly important matter. Then we will talk about more lighting effects. Here we will discuss individual lighting applications, lighting effects, and also the overall lighting, like holistic approach of lighting designs. Uh, this is one of the beautiful effect, I must say, wall washing or wall grazing effect. But out of these two, which one you like? Left one or right one? Basically, I prefer right side lighting effect because it has a smooth throwing upwards, and it's just highlighting only that patch, not distributing like giving like V-shape effect. So that's what I like the right side one. So this is a actual application of wall grazing. You can see how beautiful it is. And sometimes we are using this kind of profiles uh, as light fittings installation. Uh, Here I have added this one to highlight how they have controlled the glare. Because when you are installing something on the ground, the people who are walking, passing by those locations, will see the glare. So actually, we need to cut down the glare as well, uh, and give a smooth lighting effect. So there are technologies still developing, and these are what already developed for this glare control. And this is another thing. Uh, these special lenses trying to uh, increase the shadow of the plants. So that also will give a nice aesthetic effects when you are designing landscape things. So here the lenses really playing a big role. Now in this case, I selected many images for you because I want you to train your eye towards this aesthetic effects, aesthetic lighting designs. So that's why I selected many of the images. It's easy for me to explain also. Now, in this case, this is a simple, if you see the right side image, it's a simple reading light near your bed. But when you're not reading, it gives an option with a filter and kind of a design here, a yellow color filter, giving accent lighting on the wall. So, which is really interesting for you to have this kind of design in your bedroom or maybe your kids' bedrooms. So that's how we need to think about lighting and lighting design. And even you can change, you can add here some wording or some symbols, maybe a logo for a hotel kind of thing. So really appreciating this light fitting design in this case. Another recently evolved a word called architectural floodlights. Now, I know I'm pretty sure you have heard about floodlights because as engineers, when you're going to sites, construction areas, if you pass by those things, you may see this big floodlights. I mean, floodlight means one light source can cover a big area, and it gives a flat lighting effect. Uh, But here the term developed as architectural floodlights. Now these lights also covering a big area, but it has more, I must say, smooth, and you can have the colored lighting in this case. So big structures, big areas we can cover up with this kind of architectural floodlights. This is another example for the same. And then another thing called diffuse lighting. Diffuse lighting may be a kind of a semi-transparent material. The light passes through, then it will give a uh, evenly distribution of the space. So that's how that kind of lights we call diffuse lighting. But it gives even the distribution, but it's like looks like a flat lighting design. Even the offices, we used to have like 600 by 600 light fittings diffused with inside fluorescent tubes. Nowadays, what we do is we change these fluorescent tubes into LED tubes as retrofit bulbs. Even more than if we develop our office lighting, we can see these kind of continuous lines rather than like big 600 by 600 panels or 1200 by 600 panels. This will give like smooth lighting of the space and some kind of aesthetic design. Uh, and also you can see the right side bottom picture. They are mixing the daylight and they all have focus lighting. I mean, less distribution beam angle lights, just to give more focus onto your work rather than giving a diffuse lighting, which gives symmetrical light distribution over the space. So here you will have kind of a focus lighting, then that will people will more focus on the work. And the other image shows like you have general lighting for work, but even if you want to read, you have to switch off that, then you can switch on your reading light. So it's not that same light source. You're using all the 8 hours during the office work. You can change depending on your requirement and maybe your mood, can change the lighting. So that kind of lighting design nowadays we are doing for office lighting. So it's an improved version. I'm sure this is you're familiar with this fiber optic illumination with star lighting effects on the ceiling or as a chandelier or even underwater lighting. But one thing is missing in most of the cases in Sri Lankan projects, that is the end cap. This kind of end caps, we can add it at the corner of this fiber light. And then we can create effects. You can have a distributed star and a nice star effect rather than just a dot of light. So that's why I added this one for you. Hello. Hello.
Yes, we can hear you.
We can
Okay.
hear you.
Right. Then this is an application for museum. What do you feel about this? What do you feel about this? So this is a museum lighting. What they're trying to do with this light design that they have done for this project. They want you to, when you enter to this space, they want you to read and just go and have a look on those displays, right? So the lighting design gives you a message. So they have reduced the pathway lighting, the common area lighting, the general lighting. Basically, they have reduced it and they have highlighted the things that you need to go and see, the things that on the walls that you need to go and read. So lighting can give messages also. Here also same concept. And also it will give adequate lighting for reading or to examine the display items. But even everywhere you can see the general lighting is at a very low level. Now this I want you to understand the concept here. Now we talk about floodlights, architectural floodlights, things like that. But still, we haven't put just one floodlight and lit up the area. We have used many lights and focus the areas to cover the whole artwork. Just think about it. Here you can see the detail of the arts because this art tells you a story. So you need the support of lighting to read it. Or maybe this art gives you a message. So you will not understand if you're not properly lighting up this artwork. And also it's focusing. So this gives you a live feeling. Sometimes you feel that people are alive, not just photos. So this lighting installation is well focused on the photos or on the wall, and just only that. It's not going outside the photo frame. So that's why we feel it's a lovely, lively feeling. Again, a 3D art. So you can see exactly what are the features, and if you take some time and see this, that tells a big story. So you will start reading the story little by little. So all this because the lighting is properly done. This is another thing, remote controlled lighting. So normally we will have installed lighting in a space, and that may be controlled through a central system. But why we need remote controlled lighting? That's a question. Yeah, still projects, some of the applications, we need to control it lively. When the event is going, during the event, we need to change some things. I mean, sitting there. And also, we need to focus the light towards the tabletops. So those things, it's difficult to do with a central lighting control system, because if you are, say, if you are getting ready to an event, the table arrangement will be different. So event to event, you need to change the light setting. This focus to tabletop, the location will be changed. So you need to focus it every time. So those kind of uh, applications, those kind of requirements, we need to cater with remote control lighting. I mean, this kind of thing may be expensive for a project, but still that gives a big value to the project. So recently we did the very recent one is the Silver Ray Palmadula banquet hall complex. There, if you go there, if someone is here who have visited that location, you have seen this experience. You have seen it by yourself. Not only white lighting, there we have colored lighting also on this table tops, and it's not just RGB and RGB tablet. So what is the RGB and RGB tablet? And earlier we got only RGB lights. We call it, I mean, even normally we call it RGB lights, RGB, red, green, blue. But now the technology has developed where you will have RGB and W also, white also, to control the color of the light. Maybe that white you can have cool white or warm white. That's based on your requirement or the design intent. This is a cinema lighting. So maybe mostly we haven't seen feature lights inside a cinema. But if we have that one, that is really important, because by seeing a photo of it, you can understand that you will know that this is that cinema by the name. So that's another important thing. Uh, why we should design uniquely. Always unique design will add a lot of value to a project. So not just adding lights will not help you to improve the project values. And this one we did in 2008 or 9, I think, 2009, I think. This is a project in Abu Dhabi, St. Regis Resort, 5-star plus hotel. At that time, even though LED, we're using totally LED for projects at even that time in 2009, but their energy price is less, the electricity bill is less, so they don't care why we should invest on LED that much back in 2009. So in that case, here we have used in the ceiling not LED strips. They're called cold cathode. Cold cathode is similar to fluorescent tubes, but they are measured and built for a project requirements. What I need to highlight here is how we got this bluish tint on the walls at that time. I mean, it's not totally blue, the dark blue. I mean, if you put a blue light, it will give a dark blue effect, but this is not that dark. It's kind of a bluish tint, maybe blue color mixed with white, isn't it? Actually, yes, the lighting designers at that time, back in 2009, thought about this a lot, how to get a bluish tint, not just dark blue. So what they did is, inside the ceiling curves in the ceiling, they used 2 tubes of cold cathode, 2 lines, not just one line. One is for white light, another is for blue light. So that is how it's mixed both with the controllers and then dimmed, and we are able to get this nice bluish tint. Actually, I remember the problems we faced here, because uh, we used magnetic ballast, not even electronic ballast. So magnetic ballasts are really heavy. So we couldn't keep them on the ceiling because it's heavy. So we had to keep them in a separate electrical room and then bring the wires from there to here. But nowadays it's really easy. We have LED strips and we have electronic ballast, which are not so heavy. We can keep on the ceiling, and the installation is really easy. I think same kind of thing I have implemented. If you can go and check the photos of Nuarelia, Aralia Red, inside the ballrooms, we have used LED strips with the colored one plus white, 2 strips on the ceiling curve, because it's always the effect is different. Even though if you use RGB W, a single LED strip, it's the effect is differ when we are using 2 LED strips. One is RGB and one is white, because we are differently control these two, and the effect is really nice. This is another type of LED. I think maybe you have heard about it. or LEDs, organic LEDs. Even though it's not much popular because the manufacturing is not industrially started, I guess. Even I couldn't use still this one in any of these projects because it's not so popular. So organic LEDs, basically we can, bend it, cut it. There are some advantages of this when you are designing. It will be really helpful. So these are another type of effects, lighting effects, I must say. The lenses are developed, that plays a big role here to give one lighting 360-degree distribution. And here also in a different way, 360-degree distribution. The development of these lenses will help you to sometimes give a more aesthetic effects, or sometimes to reduce the number of light fittings that we are supposed to use to get the same kind of effect with other light fittings. So it's really amazing. This we call 360-degree distribution. And this one, it's a church project. But you can see the lighting effects, how that is placed. There are task light as well, or accent lights, general lighting. All the three layers are in place because you need reading lights on the benches and accent lights towards the statues, artwork, and general lighting and maintain the contrast. And it's amazing that how they have lit up the walls. This is a big challenge for any lighting designer. These historical places designing with light, because there are so many restrictions. You can't fix the light, you can't damage the walls, or you can't damage those structures, but still you have to give a good architectural lighting design. So this is really challenging. Why I took this one to your attention is nowadays we know there are steps, there are staircases, but when we are lighting up a staircase in a different way, not from the ceiling lights, you really need to coordinate in advance because you can't break after your construction is done. It's not good. It's not the correct practice. So keep in mind when you are designing to coordinate in advance, because when the architecture start the project, it's the same time we can start our lighting design. That's the right time. Once architect present the client their perspective images, how it will be look like, then that's the right time as a lighting designer to start. Now this one is a VIP bar kind of thing, VIP room. So you will see different lighting layers. The shelf lighting, decorative lighting, ceiling curves, and general lighting. So with this, if the interior is changing for the same thing, then our lighting also should be changed. We can't keep the same lighting sources, same location. So when you are doing a lighting design, when you are thinking about lighting designs, it's really integrated with the interior design or the architecture of the building. We can't go alone. Lighting system cannot stand alone. It should be coordinated and integrated. The same space can be designed differently. Then same time, we also have to change our lighting design to match with the interior design. To go with the interior design, it shouldn't be look like it's a different system and the interior is a different system. It should look like it's just a one system. Here is the underwater lighting, and underwater lighting also. Now, this is really amazing design because in the hotel bedroom, you will have a fish tank and you can see clearly the fish, what they are doing, what their color. I mean, it's really nice to have this kind of thing. And also lighting play a big role. And even this staircase. I mean, even the daytime they're using lighting just to highlight the staircase. And they have used the amber color, not just a white color of lighting, just to add more interest to the place. I mean, even in the daytime. This photo I got from my friend. So how they're thinking about lighting, what they're going to, I mean, what they're trying to do. Here's another good example, like how the candle light used in this design. This is the same project as I showed you earlier with the cold cathode thing. Now here I have a very famous question for you. Uh, how many direct light sources you can see here? Can I see in the chat? How many direct light sources you can see here? Okay, I'll tell you. Now, all these, I mean, almost all these lighting effects are indirect because ceiling curves are indirect lighting. These pendants, decorated lights are diffuse. That's also not direct. And the wall LED strips going around these wall features, that is also inside, not visible. So that's also giving indirect lighting. And even the bar count phase also you will get indirect lighting because that's also LED strips inside that feature. Uh, the only thing remain is the candle light as a direct lighting, but there's no down lights from the ceiling. I hope that you have captured. So that's how it's giving very relaxing uh, environment. It's creating a very relaxing environment without down lights directly from the ceiling. This is also one of my projects. I was involved in the construction phase. But the lighting designer won 2 awards for this project done that year, from Light Middle East. One is for facade and landscape, what are the important, I mean, what is the point to win that is this facade, this hotel facade, it's not lighting up whole facade at once. Only selected features are lit up. So that's the main point to win that award and that tier. What do you think of it? The relationship between dark and light and the shadow of it. Shadow is, again, we can say dark. So how the shadow is created, that's amazing. This is an open theater. So you can see a stick with a light here, and that's creating the shadow in different angles. It's just not one. And also all these rechargeable lamps kept nicely, arranged it nicely. So you can understand, like, it's not a huge cost for energy as well. Another walking path. First, where your eyes stopped. First, I saw the this picture on the roof, this artwork on the roof. So see, it's highlighted with the light, not the total roof, but only the artwork. So our eyes first goes there. Another concept is called modeling. Modeling where we have light sources, we are placing around it, and without shadow, we are trying to cover it. And this is called modeling. I mean, if I explain it simplest way. Basically, the statues, the 3D stuffs, we need to understand which faces we need to highlight, the people, which faces the people will see. So we need to cover those things. We'll try to cover it without shadows. That's the challenge. Another word is brilliance. Brilliance is something glowing itself. So basically all the chandeliers, all this decorative lighting you see in, say, ballrooms, banquet halls, with glass and even crystal. Crystal has more nice effects than glass, of course. So it will glow itself, and even giving some lights also as general lighting. So this is called brilliance effect. So you see this all everywhere, it's data. But if you reduce the general lighting, you will be able to highlight what you really want people to see who are coming there. Now there are some concepts like here you can see whether wall we keep bright or walls we keep dark. Maybe the same thing, the ceiling we keep bright, or ceilings we keep dark. So in that cases, we can say, we can see like relaxing modes. We can see calm and quiet modes, well focusing modes. Likewise, you can create different scenes uh, while selecting where we really want to light up. Now in this staircase also, normally this LED strip going with the steps, that's the feature light. But task light, where you need to step up or step down, giving from the ceiling. Because most of the cases it happens in the other way. From the wall mounted light fittings, we'll call them step light or pathway light, and we'll get light to step up or step down from them. But here it has differently designed. I think you know this project. This is the largest water fountain in the world, located in Dubai. So even water features, we need lighting. Colors in design. I mean, here we talk about red, green, blue, purple, orange, all these colors, not white. I mean, earlier days, people afraid to use colors. Maybe one reason the colors are so dark and not smooth colors. But nowadays, it's developed to have smooth colors. This is done way back, maybe even before 2007 in Dubai. A water feature using colored lighting, and it's color changing time to time without knowing, because the shading time is given longer. I hope everyone knows this one. Have you thought about lighting design, lighting scene settings when you're watching a film? Next time you can examine carefully how the lighting is set, how the lighting helpful to improve the situation, improve the scene. Now here also they have selected certain things only and then later, not everything together, everything at once. It's layered approach. Some layers are lit up and some are in dark. So that's how they have created the scene so attractive and giving a message to you. This is one of our project in 2009. This consists of 4,899 RGBW lights back in 2009, and individually it's able to control. Individual light we can address and control, and we can program it in such a way that we will have like waves kind of things, maybe the country flag colors, maybe add like Coca-Cola colors and things like that. So we can program it in any way to give a nice lighting show. Actually nowadays uh, we need some media kind of designers when we are doing some attractive facades. This is also an example for colored lighting. This is temporary installation for competition, but still you can see keeping focusing the white light towards the statue, but the rest of the areas uh, putting some colored lighting and giving a direction. Nice city lighting, a city view. I mean, during the night time, when these crane stops operate, they use as architectural lighting feature and giving some colored lighting. So in this, people who looking at that, be happy to see it. Especially countries like us, where we have a lot of construction going on in the Colombo City area. It's really nice to kind of limit those white floodlights and add some artistic effects. This one you can understand that it's a tall space, but lighting is improving that idea. I mean, supporting the idea of that tall space. Again, colored lights used nicely in a space. This is designed by a Dubai designer, one of our friends. City lighting in Dubai. Do you like to have a city like this? Maybe if we can convert Colombo city, at least. So lighting play a good role, big role, especially countries like us, because we are based, our main, one of the main income is tourism. This is called Dubai Eye. So since Dubai also a tourism country, they develop a lot of projects to attract the tourists. This also my previous company did this design and opened it in last year. A lot of colored lights are used. Again, a colored lighting facade for the building. I mean, you can move a dynamic. It's a dynamic lighting system most of the time, changing the color according to a pattern and giving some messages to the city people. Giving a surrounding color as blue, but highlighting it with very warm light. Even underwater lighting, maybe you have seen a lot of color changing lights used underwater. Here, a difference I have seen is the beam angle. Very wide beam angles are used to flood the color under the water. I hope you can understand what this area used for. It's a storage basically. But what they have done, even the storage area also they have added colored lighting and make it so attractive because people can visit that place and appreciate this design. And it's a marketing point as well. Here, what I need to highlight is the blue light mixed with white light in the design as a facade feature. Here is another light source, single light source giving different colors. These are, I think, still in the testing modes. But see the environment. The first one gives a warm feeling, but the second one giving a cool feeling. Dark skies, night friendly lighting. So nice sky scene. Do you have this in Colombo? Some of the developed cities, they can't see the stars in the night. You know why? So there's an association called Dark Sky, International Dark Sky in USA. So they are more they are more into this, saving the dark sky in the world. And they are giving recommendations and a lot of information for us to design lighting accordingly. So to save the dark sky. So International Dark Sky Association that talks about light pollution, effects on wildlife and ecosystems, light pollution, waste energy and money. So we can save energy and money also if we avoid this light pollution. And it's good for safety and nice night sky heritage and good for human health as well. How we can improve it? So this shows like control our beam angle, control our light distribution, and also add timers. Those are the two main things. And also another thing is the color temperature. This way we can convert the cities and reduce the light pollution. So basically they recommend some of the light fitting types. I mean, basically controlling the distribution. So the first one is very diffused one. It gives every direction, but the second one gives only where you need lighting. Well focused. So here I think you can understand. We can cut the glare also, and the useful lighting, which area we need to focus, and accordingly we can limit the beam angle or the light distribution. So there are things like called dark sky parks where you can go there and see the nice, beautiful sky with the stars. So from here you can understand how people polluted the cities with light. So this is the transformation they are looking for to limit the lighting distribution, angle, direction, and reduce the glare, and asking us to take action by ourselves and transform this to a better cities, better environments. These images, I think you can have it from internet. So how the cities are polluted with light. So it should be balanced and effective solution for the city. So next one is, I hope you will, you need to know what are the lighting design related professional organizations. So this is a list of those things. You can get memberships, you can go to those websites and subscribe to newsletters, then you will get newsletters. And in their website also a lot of information are there. You better go and read them. So if you are starting from your own, first thing is you need to analyze your project. What type of project, what are the conditions, what are the special features that looking for, and what are the applicable standards for that area or for that country, and glare limitations, luminaire color, color rendering index, and environment is to be illuminates, how it is used, I mean the spaces, what is the requirement of those spaces. You can break down the spaces, who will use it, what kind of people will use that, and style of the architecture, and what is the interior design of it. So many things you can study and then start thinking of applying lighting for that particular project or space. Another thing is you can start with your lighting now. If you know the lighting, architecture design or the interior design or the landscape design, you can simply sketch your ideas and improve it. So this is, I think, where you can start. So it's really easy. For lighting designers, the sketching is a must, because this is where we initially communicate our lighting ideas with the other designers or the consultants or the client in the project. Even now you can start, you can find out a nice attractive image from the web and make it black and white, and then use a yellow color pencil and sketch, I mean, how you want to light up that space. So further we can develop project locating light fittings in different ways, because if you are starting to do that, there are many ways. I mean, it's not just one way. Downlights, wall washers, even same lighting effect you can have with different light types. And now this corridor, you will have different designs. Here 3 designs are shown. Even the staircases. This is kind of a typical office arrangement. And then you can improve it. Kind of a boardroom, auditorium, you can start with the directional arrows also, where it's going to direct. So this is one of the project I told you about, Silvere in Palmadulla. So once we get this design from the architect, so this is the image that we got from the architect, telling that this is the lighting, this is the architecture or the interior design going to be. So we developed on top of that our lighting scheme like this. So it's really focused on tabletops, wall washing, LED strips or the ceiling coves, then the decorative lighting. And how if we increase the lighting level, because we need dimmed version and also the increased version as well. And the colored light, and this is more important for wedding hall, because they have sometimes theme colors. And this is another project, a temple project in Australia. We got this design from the architect, and then we developed our lighting design. Even Silvere, you may have seen it in the internet, or you can have go to YouTube and see some of the videos are there. But this one is under construction still. So this is how we have developed our lighting design. When there is an event, the light levels are increased. But for a normal use, daily use, just, you know, more relaxing, lighting levels are maintained. So basically, and the finally, to summarize, lighting, architectural lighting design is not just lighting up the space. I mean, the first one shows just lighting up the space, but we need to transform this into a more user-friendly, maybe cost-effective, maybe energy efficient, and then aesthetically present lighting design. So this kind of transformation we expecting from our architectural lighting design. So thank you. That's all about the presentation. I think I can hand over this to Sandhya.
Thank you very much, Engineer Nilusha Rajapaksa, for that enlightening keynote speech on architectural lighting design. Your expertise and insights have truly provided us with a deeper understanding of this field, of course. French architect Le Corbusier once said that light, space, and order, those are the things that men need just as much as they need bread or a place to sleep. So starting from today, I think most of us will never look at a lighting design as the way we did before. Engineer Lucia, thank you so much.
Thank you.
Okay, welcome. Okay, now I would like to open up the forum for the Q&A session. Dear participants, please feel free to raise your hands or type your questions in the chat box. We would like to take them one by one them with Engineer Nilusha. In the meantime, to start off, I would like to ask some questions from Engineer Nilusha. Engineer Nilusha,
Yes,
my
I
first
can hear
question
you.
is, okay,
Yeah.
my first question is, our participants joined with us today will be curious to know the demand for the lighting engineer, sorry, the demand for lighting designers in the international market and how the profession is evolving to meet the needs of the industry. With your expertise, especially in Dubai, can you explain the career opportunities, especially in the international market in this area?
Yeah, there's a huge vacuum for lighting designers, even in Sri Lanka, because I haven't seen any of the architectural lighting designers emerge from Sri Lankan market as well. Even international market, uh, because not even like Sri Lanka, international market, all of these projects like hotel projects, even apartments, city lighting, city designing, all these projects they should have a lighting designer in their designing team. So this is a evolving profession, uh, and there is a huge market for them. If you're going in the right path, surely you will have a lot of opportunities. uh, I think like in international market rather than the Sri Lankan market.
Okay, thank you very much, Engineer Nusha, for giving us an idea of the emerging trends in architectural lighting design. As we understood, the project lighting design stages, the stages of stages of lighting design are the more important in those massive commercial projects. Can you give us some further explanation on these design stages, please?
Yes, Sandima. Now, if you are designing a project, there are designing stages that all the architects, interior designers, all who are involved in the project, even structural engineers, they are following. This is an international practice. I mean, they are called REBA steps, or REBA. They are following REBA with their membership. So first thing is in lighting, we have concept design development. So once we get all the detail from the architect, interior designer, client, once we gathered all these requirements, we are going with the concept design. We try to do sketches as I shown, and maybe Photoshop renders. So we are going to present the concept design. So this will have a coordination meetings. This will have some time for uh, some of the coordination or the understanding the requirements. Then once it is approved by the design team and the client, then we go to the next stage. We call it schematic design. So schematic design, we try to do some drawings. Our concept design, we are trying to convert it to drawings. So some basic specification or some kind of a schematic design for the controls. Likewise, we try to develop some kind of documentation. Then we send this again to our design team, and we coordinate it and get it approved with maybe some comments. After that, we are going to detailed design. In the detailed design, we are going with everything with in detail. I mean, if we done layout drawings in the schematic drawing, now we have to go with elevations and blow ups, like small details, detailed drawings. Then the specification in detail with the full terms, say lighting specifications. Even if take one type of light, we will have maybe 20 parameters to specify. So wattage, CRI, color temperature, finish of the light fitting, efficiency, efficacy, lighting control method, photometric data. Likewise, we will have a lot of detail on this specification. So this is called detailed design. Sometimes we call it technical development as well. And also the lighting control, if it is in place, how it is controlled, what are the central lighting control system, how it is designed, the locations, everything will be decided and put it into documentation. Then I think this kind of stage is appropriate to go for a tender for the client. Then after tender, we will have a construction issue, and finally, I mean, the construction issue is the project is going to execute, and during the execution, we will have questions, we will have site visits, we will have mock-ups. After everything, we will hand over the system to the client if the testing and commission is successfully completed. So basically, these are the project stages that we are following as lighting designers.
Okay, thank you so much, Engineer Nilusha. So Dr. Tilak Sibalapitia is with us, and he has a question. Sir, it's your chance to.
Thank you very much, Nilusha, for the excellent presentation and for your contribution to the profession of lighting designs, and very specially for sharing your thoughts and sharing your work that you've done elsewhere with Sri Lankan professionals. Also, one comment, I think you had a significant contribution to the lighting design of the Kalani Bridge. So perhaps you forgot to show that to us. That's a comment, but I have two very simple questions. The color rendering index is usually marked on a bulb. I'm talking about bulbs that are commonly available in the market on a scale of between 1 and 9, if I remember right. Now, how does that scale relate to the scale that you were presenting in your slides on CRI?
Thank you, sir, for your comment. It's really helpful for me. The CRI is normally it's 1 to 100. So basically, they will say CRI 80 or more than 80. That kind of indication we can see in the industrial bulbs. Is that the thing?
Yes, I guess that's what it say. For example, I've seen Philips and National when they actually mark the product identification, they use coding such as 830. So we'll have to decode a little bit, and 8 means 80, 30 means 3000 K. So this kind of markings I have seen. So it's for a practicing engineer, sometimes it's very confusing because the theory is a lot more detailed, whereas the practice is so brief. Any comments on that?
Yes, sir. Even though they have marked CRI 80, the R9 index is very low in the bulbs in the industry in the market. Even though the CRI is a calculated average value, they will maintain it 80 or higher than 80, even though they are keeping the R9 value is really low. So that's why we are not seeing the red color properly with those light sources. So if you go in detail, specific project like museum, color sensitive. So we have to check the R9 as well, where it lies.
Fine. Very last question. What is the worldwide thinking about the lighting devices to be used for street lighting or highway lighting or expressway lighting? The thinking perhaps several decades ago was to go for the highest efficacy on sodium vapor lighting by sacrificing the color rendering index. But with the LEDs being available, perhaps a little bit lower efficacy. Is the worldwide thinking moving towards the use of LED lighting for street lighting?
Yes, sir. Now all the cities are moving with LED. I mean, they are transforming to LED. Even Paris or whatever the city you name it. Even the Asian countries like Bangkok, city like those cities also, they are coming up with local regulations, and they are trying to convert all these to LEDs. And also we are getting, I think, ADB funded funds for this, because recently also we did lighting, street lighting assignment, just to give lighting regulations for Sri Lanka, like creating lighting regulations or lighting design for the whole country. There also we recommended LED lighting with design. So that is the trend, and the
Fine.
funds
Thanks. Yeah.
also to transform that to LED. That's the base idea.
Yes, that's right. I think we all have to work towards getting our street lighting correct, because I think, in my view, Sri Lanka is in darkness in the night, which is very sad. And even the little bit of lighting that we have is not properly designed or properly maintained. So perhaps if Sri Lanka gets this act right, we should also be able to access funding and move to a good, high quality and properly designed lighting system. So thank you very much, Nilusha. Personally, I'm very proud of you and your company and your work in promoting proper lighting designs. And thank you for the beautiful presentation. Thanks.
Thank you so much, sir. He's one of our lecturers in university as well, so we have learned from you a lot. Thank you so much.
Dr. Tilak Sivalavidya, thank you so much for your valuable comments. And Engineer Nilusha, we have a few more questions. Actually, questions are flooding, but we have to summarize them. So now the next question is, how do lighting designers incorporate calculations and simulations using software tools into their design process? Can you give an example of a project where this approach was particularly effective?
There are many softwares available in the market. Some are free and some are we have to pay. Mostly I'm using Dialux, because I'm the Dialux trainer also for Dial Germany. These softwares are very useful because when you're doing a project, sometimes even with our experience, we set the lighting specification with certain lighting lux levels, but we need to prove it, whether we are really achieving with those things. So in that case, it's good to simulate it and show it that we are achieving it. And that will be a document for even for the client team or the consultant team, just to check after a project is constructed, whether we really achieving it. That's one thing. And the other thing is, like, example of this is street lighting designing. When we are doing that, for us to optimize, I mean, these street lighting projects are based on the values, lux level, how we achieve, and the how the distribution of the lighting. So then for us, it's really easy for us to optimize the solution with using this softwares. So Dialux is one of the most commonly available, freely available. I hope engineers they already know this software because it's easy to learn. All the tutorials are available in the YouTube, and I also recommend for you to learn it, start learning and use in your projects as much as possible. Then you will notify, you will understand the advantages of it. Yes,
Okay,
Sandeep.
thank you.
We
Okay,
can
thank
go
you.
to the next.
Yeah, yeah. With that answer, I have one question. Like, can you walk us through the steps of documenting a lighting design, including the standard practices or any industry standards or best practices that are followed?
Yeah, the best practices I can say with the international experience and the way they are doing internationally. Documentation we are looking for basically for the first thing is our concept design document with our renderings, the initial proposals, initial lighting effects that we communicated with the client and the design team. So that's the first document that we need to maintain, because sometimes if architect is changing the design, and accordingly we also have to change, we can't stick with the old design. So that is the first document, I must say. Then the second one, we will have layout drawings. The layout drawings, normally it's going with AutoCAD 2D version, but we may use Revit, BIM models nowadays for projects to draw our design. Then the layout also we can put it into two layers. One is called RCP layout, that is reflected ceiling plan, which are the lights coming on the ceiling. We can put it in that plan, and then we can go with another low level plan for the same area, which will have our wall lights, floor lamps, table lamps, or floor lights, things like that. Then we may have elevation drawings to show our lighting, where it's fixed in which method, I mean, with more details. And also called detailed drawings with some blow up of those installation methods. Then our lux level calculation reports using our simulation software. So that also we can keep as a record of calculating. So then the next one is specification, light fitting specification. The light types that we use for each application, we will have a separate document showing parameters of each light. As I said earlier, we will have maybe 20 or more than features we are specifying for just one single light fitting. So that's called lighting specification document. Then if we have lighting control system in place, so we will have breakdown in circuits, breakdown for groups of lights to control individually. So this information we will separately recorded in lighting control schedule. So there you will have the circuit detail plus the controlling method, controlling device details. Then we can have lighting control schematic drawing for the whole project, where the lighting control panels are located, how they are interconnected. Likewise, so those are the basically lighting design documents that is required for a project. This may be have breakdowns according to the stages that we follow. I mean, which the stage we are submitting this document, and which kind of information required for that stage. Likewise, we may have breakdowns as well.
Okay, thank you, Engineer Nilusha. Actually, it's been a while and we really appreciate your energy that you are explaining all the questions really well for our audience. And now we have only two more questions. I'd like to give the opportunity to Engineer Azir, who has been raising his hand since the beginning. Engineer Azir, it's your time. Engineer Azir,
You are
are you-
unmuted. You are muted, Azir.
Engineer Azir, are you with us? Okay, let's move to the next question. While Engineer Azir is being online. So our next and our very important question, like a remarkable question for you. Engineer Nilusha, as a lady engineer, we appreciate your courage and dedication and in the vast international experience. So Engineer Nilusha, what is the message you have to give our lady engineers and undergraduate students who join with us today?
That's a good question. Actually, I must explain it. I mean, being a lady engineer, you will have more challenges than others, especially when you're working as a lady engineer at site in construction industry, where I have experience. So think smart. That's the first thing, right? If you think smart, you can avoid all these issues, all these problems coming towards you, and don't stop dreaming. If you have a dream, go for it. Don't listen to any other negative things. Now, if I start my career, I started my career from Dubai, not even in Sri Lanka. My first job I got to Dubai. When I was in final year, I checked the newspaper and I saw some advertisements for Dubai engineers. So nobody think that lady engineer will apply for it, right? But I applied and I called for interview in Colombo, some location. Then I went and I faced the interview. It was, I can remember, 45 minutes interview asking all the technical stuffs related to electrical system design. Then after 45 minutes interview, the interviewer told me you're selected and see you in Dubai. So I was so happy, but you know, everybody giving me some negative feedback because construction industry, there can be accidents. I mean, many accidents are there. So lady engineer how can you alone work in country like Muslim country like Dubai? So I heard a lot of things, but I thought I should get that challenge. I shouldn't be feared. And then I planned to go there alone. So the company was really good to me because I was so energetically giving my 100%, say more than my 100% I gave to that company. So that is another thing, how you can win your superiors' attention. You don't give your 90% to your company. You have to give your 100%. Even the day before I had my flight, I got an advice from my relative. If you are getting 1 rupee from your company, you have to give your 2 rupee work to the company. That's how you should get that 1 rupee. So with that thinking, I started my career. So So I try to give my more than 100% to the company. So that is, I can say that is the turning point. So that is how they recognize and even helping me out. Because sometimes there are restrictions, sometimes there are problems, but everything I was able to resolve, uh, giving my 100% to the company.
Okay.
I think, yeah.
Yeah, thank you for those informative answers, Engineer Lucia. We have all got the opportunity to learn about how impactful architectural lighting design is. Ladies and gentlemen, let's give a round of virtual applause to our amazing keynote speaker, Engineer Lucia Rajpaksha, for sharing her expertise on architectural lighting design with us. Your insights have truly illuminated our minds, and we are grateful for the opportunity to learn from you. I'd also like to express my appreciation to all the participants uh, for actively engaging in this session. And your questions were insightful and thought-provoking. And we are grateful for your presence here. We have a surprise for our keynote speaker, Engineer Nilusha Rajapaksha. We would like to present you with a small, symbolic, official token of appreciation for sharing your valuable knowledge and insight with us today.
Thank you so much, Sandhya.
You're welcome. Please give us some time to share it in online in this screen. I hope you can
Thank
see
you
it.
so much. Yeah,
Yeah.
thank you
You're
so much.
welcome. We really appreciate you. Okay, before we conclude the webinar, let me hand over to Engineer Kosala Vidhanapathirana, the Secretary of the Electrical, Electronics and Telecommunication Engineering Sectional Committee of ISL, who will be delivering the word of thanks and officially bring this session to a close. The Engineer Kosala.
Yes, Sandeep. Yeah, my duty is to deliver the word of thanks. Dear distinguished guests, ladies and gentlemen, on behalf of the Electrical, Electronics and Telecommunication Engineering Sectional Committee of the Institute of Engineers, Sri Lanka, I would like to express sincere appreciation to all those who made today's webinar on architectural lighting design a success. Firstly, we would like to extend our heartfelt gratitude to Engineer Nilusha Rajapaksha, Director of Candela Lighting Design Private Limited, for her invaluable contribution as the speaker of today's webinar. Her extensive knowledge and experience in the field of lighting design have undoubtedly provided our audience with valuable insights that will serve them in their professional endeavors. We would like to thank Engineer Dr. Kamal Laksiri, the President of IESL, for his tremendous support in ensuring the success of this webinar. His leadership and guidance have been instrumental in the IESL's continued success in organizing these sort of events. We extend our appreciation to the staff of IESL, including the Chief Executive Officer, Engineer Neela Desekara, for their tireless efforts in organizing this webinar. Their hard work and dedication have ensured the seamless execution of this event. We would like to acknowledge the contribution of all the members of the subcommittee for organizing public lectures and memorial lectures, including Engineer Navodana Kankanange and affiliated engineer Janaka Pereira, who introduced the speaker to the sectional committee. Finally, we express our gratitude to all the participants who have taken time to attend today's webinar. Your presence and active participation have contributed to the success of this event. Once again, thank you to all involved in making this webinar a success. We hope to continue organizing such events that benefit the engineering community in Sri Lanka. Thank you. Good night.
Thank you.
Thank you to Engineer Kosala for those words of appreciation. As we wrap up this webinar, let's take a moment to reflect on the valuable knowledge and insights that we have gained. We hope this session has inspired you to explore further, and continue your learning journey in this field. And once again, a big thank to you, Engineer Nilusha Rajapaksha, for being our beacon of light and sharing her brilliance with us. Thank you once again for joining us today, and we hope to see you in future webinars of the Electrical, Electronics and Telecommunication Engineering Sectional Committee of ISL. Wish you all the best. Good night.
Thank you. Good night.
Good night.